In this video, we're going to be talking about hydrocarbon refrigerants. Now, the important part about hydrocarbon refrigerant training is that we talk about safety. Everything we gain through this training, besides a little bit of a brief history and how they work, we need to be thinking about safety. Remember, hydrocarbons are extremely flammable. That's why we have a separate certification process. It is not legally required that you get this certification. However, the hydrocarbon refrigerants training certification through HVAC Excellence is a good thing to set a standard with. It's actually developed by RSES. So what we're going to be talking about is the uses of hydrocarbons as refrigerants. We're going to be talking about hydrocarbon regulations and standards. We're going to be talking about refrigerant properties and safety. We're going to be talking a little bit about the refrigerant cycle, even though by now most people should already know that if you come this far. Don't play with hydrocarbons if you don't know the cycle. We're going to be talking about system components, and we're going to be talking about servicing. Now, just a brief history of refrigeration. In the 1900s, hydrocarbons were used in the refrigeration industries. In the 1930s, CFCs were developed because they're non-flammable and hydrocarbon use reduced. In 1950, semi-hermetic and hermetic compressors were introduced. 1970s, ozone depletion by CFCs were discovered. In other words, chlorine was now found to be one of the primary reasons of ozone depletion. In 1980, HFC and HC started to replace the CFCs. 2000, we started to see hydrocarbons being used in ice cream cabinets. 2005, over 50,000 hydrocarbon cabinets are used in Europe. And the use of these just starts swelling over time. The purpose of this training is we want to establish best safe working practices with approved flammable refrigerants. These are R290, which is propane, R600, which is isobutane, and R441A, which is a flammable blend. Now again, all of these are flammable refrigerants, and that's why we have to worry about safety. Why are we switching to flammable refrigerants slowly and surely? First, the Montreal Protocol, USA EPA SNAP, global warming, and they do have an increased efficiency. The one key point of all of this change is technician servicing procedures have to change with the introduction of flammable refrigerants. Technicians have to be very aware of what refrigerants they're working on. They have to be very aware of their surroundings, and they have to be very aware of what could cause something to catch on fire or explode. Example, okay, you're working on a flammable system, an R290 system, under the line near the grills of a restaurant. Are you going to want to be there opening the refrigeration circuit and have the chance of a leak or chance of a flammable situation when there's a gas-powered grill running next to you? Probably not. So it's tough to think about like that. You also have to keep in mind that there's a thing called a upper explosive limit and a lower explosive limit. Okay, so it's an air to fuel mixture ratio. If you have too little air, it's not going to burn. If you have too much refrigerant or propane, it's not going to burn. So when a system is a sealed system and completely full of propane or R290 and you don't have any air in the system, you're all set. Okay, it's not going to burn. But the minute you start mixing the propane or whatever other refrigerant blend you're using with air, that's where it starts to have possible flammability issues. So around the world, okay, in domestic refrigerators, over 80 million are in use in worldwide. Start taking a look at some of the labels of domestic refrigerators, the data plates. Start looking at some of these as you shop in Lowe's or Home Depot or any of the other appliance and home improvement stores. Okay, you're going to start seeing the flammable refrigerants in the system. Split systems and portable AC systems in use from many suppliers. They're not yet approved in the US. Okay, For split systems, we're probably looking at 2023. For window units, however, if it's under 18 ounces, I believe is the classification, Windows units are allowed to be using flammable refrigerants at this point. For commercial appliances, you're going to see the flammable refrigerants in bottle coolers, chest freezers, and commercial refrigerants. They're already out there. Great example of a chain that has them already, Dollar General. The approved flammable refrigerants at this time are R290, R600A, and R441A. Okay, the R441A is a blend. R290 is pure propane, not the type you have in your grill, okay? It's a much purer version. R600A is isobutane. R441A is a mix of R170, 290, 600A, and 600. It's a blend. R600A and R441A are being used in new household refrigerators and refrigerator freezers, usually as 57 grams or 2.0 ounces. Equipment must be constructed following UL 250, the current edition. R290 is used in new retail food refrigerators and freezers. It's 150 grams, 5.3 ounces of refrigerant. Equipment is constructed following the UL 471 current edition. You cannot retrofit hydrocarbon refrigerants back into, let's say, R410A, R134, any of the current systems, any of the traditional systems, you cannot retrofit it back into. So let's talk a little bit about understanding the hydrocarbon regulations and standards. So EPA, CSA, ISO, ASHRAE, UL, IEC, EC, and NFPA all affect the regulations of hydrocarbon refrigerants. In the United States, we are more concerned about the NFPA regulations, the UL, and the EPA. Okay, in Canada, we're worried about the CSA, the NFPA, and the UL. The rest of these organizations have to do with the creation of the standards. Ultimately, the technician is responsible for knowing the local regulations. You need to check with the authority having jurisdiction for local regulations. There are some buildings you cannot install flammable appliances into, okay? And there's some restrictions in some jurisdictions on how many you can put in here. Again, it contains a flammable substance. Regulated use and equipment applications for U.S. regulations. You can see the federal websites, EPA.gov, EPA SNAP. For charge size, new household equipment can have 57 grams, that's 2 ounces of 600A or 441A. For new retail, you can have up to 5.3 ounces of 290. Now, those are the maxes right now of what's allowed. So, therefore, split systems do not currently have propane. New systems are only allowed under the SNAP approved program. You cannot retrofit in the U.S. from a prior refrigerant to hydrocarbons. Retrofitting is allowed in other countries. Okay, but in the U.S., you may not retrofit. Look for matching refrigerant equipment labels. The unit and the compressor have to match. If the compressor and the refrigerant match, then it should be acceptable to service the system. If the labels do not match, assume the system has been retrofitted. Stop working on the system immediately. Contact the owner, inform the owner of system violations, and refuse to service. Offer to replace the system with approved systems. This is actually a pretty serious statement here. Okay, do not service retrofitted equipment. The minute you service it, you assume liability. There's some EPA further information here. Qualified refrigerant technicians must service this equipment. You have to be familiar with the safety precautions for flammable refrigerants. You have to be familiar with the information provided by other sources, such as the manufacturers of the system equipment, component manufacturers, and the refrigerant suppliers. Compressors in the system will have labels identifying the type of flammable refrigerants. UL 250 and UL 471 require the labeling as part of SNAP approval. Again, look on the compressors. Okay, look on the system. You'll always see the type of refrigerant there. Attach on or near any evaporators that can be contacted by the consumer. Danger, risk of explosion or fire, flammable refrigerant. Do not use mechanical devices to defrost refrigerant. Do not puncture refrigerant tubing. Okay, again, we're dealing with areas that may have employees that are assigned to like defrost the freezer, get the ice out of it, stuff like that. We need to make it clear that the person that's defrosting should not try to use a scraper, knife, fork, or whatever on the evaporators. We also have to have an attached label near the machine compartment that's near the compressor, condenser. Danger, risk of fire or explosion, flammable refrigerant used, to be repaired only by trained service personnel. Do not puncture refrigerant tubing. Okay, you have to have something both on the evaporator side where the customer can get to it, and notice near the machine compartment where a service tech can see it, that there's flammable refrigerant used. It has to be very clear. You should also attach near the machine compartment another label that says caution, risk of fire explosion, flammable refrigerant use, consult repair manual, owner's guide before attempting to service this product. All safety precautions must be followed. And then on the exterior of the refrigerant, again, another warning label someplace. Caution, risk of fire or explosion, dispose of properly in accordance with the federal or local regulations. Flammable refrigerant is used. And then any and all exposed refrigerant tubing also has to be labeled. Again, caution, risk of fire explosion due to puncture of refrigerant tubing. Follow handling instructions carefully. Flammable refrigerant being used. All of these markings shall be in letters no less than 1/4 inch high. And again, you're always going to see the metric thing, the metric equivalents here first. And the reason is most of the hydrocarbon refrigerants started being used in countries other than the US that are on the metric system. So again, 6.4 millimeters, 1/4 inch high. These letters need to be visible. The refrigerator or freezer must have red phantom matching systems number 185, that's just the paint color, marked pipes, hoses, and other devices through which the refrigerant is serviced, typically known as the service port, to indicate the use of flammable refrigerant. This color must be present at all service ports where service puncturing or otherwise creating an opening from the refrigeration circuit to the atmosphere could be expected. An example of this could be the process tubes. Color mark must extend at least 1 inch from the compressor and must be replaced if removed. In other words, if you remove the paint, you have to repaint it. Working with any refrigerant carries a certain liability. Okay, once you are certified, licensed, or trained to work with a certain refrigerant, you have a liability for what you do. Check with your insurance carrier before you begin to work with flammable refrigerants. Okay, your insurance coverage or your company's insurance coverage could exclude flammable gases. You need to be very careful on that. So let's understand the refrigerant properties and safety. We start off with our basic ASHRAE refrigerant rating. If you take a close look at this chart, you'll see that we start with A1, which is lower toxicity and no flame propagation, and we go all the way up to B3, which is high toxicity and higher flammability. Now, many of you have seen this chart before. However, we now have added A2L and B2L. A2L and B2L are lower flammability refrigerants. Okay, and they've been added through ASHRAE standard 34 for details. Okay, but every refrigerant you deal with will be rated on this flammability toxicity chart. Flammability and ignition requires fuel, air, and ignition. Okay, we have to have all three components before we have flame. A sudden release of refrigerant can result in proper concentrations for a flash fire, a sustained fire, or an explosion. Again, fuel, air, and ignition. Okay, so let's take our restaurant reach-in freezer. Okay, the little reach-in that might be near a grill in a restaurant. Okay, if we puncture the tubing or release the refrigerant, granted, it's not much in there. It's like a maximum of 5.3 ounces. But still, when the refrigerant was in the system, it has no air. Okay, we create a puncture or we release that refrigerant. All of a sudden, I now have pure propane mixed with air. All that's left is to need an ignition source. Well, you're next to a grill. There's an ignition source. Okay. Suffice it to say, it's not a good idea to smoke while you're working with propane equipment, even if you're on a roof someplace. Don't light up. Okay. Be very careful when using torches. Okay. Ignition sources are temperatures greater than 860 degrees. Could be flame from a match. Could be a torch, including halide leak detectors. You do not use halide leak detectors with flammable refrigerants. Could be electric sparks, like from lights and light and switches. Could be unsealed relays and overloads. Could be on and off switches. Could be contactors. Could be pressure switches. Could be defrost timers, thermostats. Could be vacuum pump switches. Could be electronic leak detectors. Okay, you have to be very careful with everything you use. Now, upper and lower explosive flame limits are extremely important when you're dealing with hydrocarbon refrigerants. The LEL, which is the lower explosive limit, okay, is the lowest air-fuel ratio that you can have to have flame. For R290, it's 2.1%. For R600A, it's 1.8%. Okay? The upper explosive limit is the maximum air-fuel mixture that's required for flame propagation. For R290, it's 9.5%. For R600, okay, it's 8.5%. Again, LEL, okay, the lower explosive limit is the lowest concentration or percentage of a gas or vapor in air capable of producing a flash fire in presence of ignition source. Could be arc, flame, or heat. At a concentration in air below the LEL, there's not enough fuel to ignite. The upper explosive limit is the highest concentration or percentage of a gas or vapor in air capable of producing a flash fire in the presence of ignition source. Concentrations higher than the UEL are too rich to burn. Currently, there's no field equipment for determining the ignition concentration percentage. Therefore, ignition sources must be avoided at all times. All substances are required to have material safety data sheets. They're required to be available to all employees. They're required to be available to local fire departments. Again, check with the authority having jurisdiction for local regulations. OSHA requires MSDS sheets, or safety data sheets as now they're known, to be available. Okay, now we're going to talk about some general safety. Okay, we're going to talk about handling these refrigerants. We're going to talk about the properties. We're going to talk about the boiling points. We're going to talk about combustible gas monitors, and we're going to talk about interactions with other chemicals. When you have a cylinder of R290 or any of the hydrocarbon refrigerants, you want to never store exposed to temperatures above 125 degrees Fahrenheit. You never apply open flame to a cylinder. You never heat with water or a heat blanket above 110 degrees. You never refill single-use or single-trip cylinders. You never exceed the refillable limits. You never remove labels, and you never smoke near flammable refrigerant cylinders. Don't do it. For transporting cylinders, the Department of Transportation Division 2.1 classification for flammable gas applies. You transport it in an upright position. You have to label the vehicle as carrying a flammable gas. You have to inventory the vehicle contents. In other words, every single flammable thing in that vehicle needs to be accounted for. Some jurisdictions requires transport in explosion-proof cabinets or venting of the cabinet to the exterior. Again, check with the local authority having jurisdiction. If you're going across state lines, you have to check with the United States Department of Transportation. Cylinders stored should be stored in a locked cage, stored at ground level, stored away from air intakes, and stored in a place where there's no ignition sources. You want to limit access, and you need to install a combustible gas monitor. Again, check with the local building office and fire department. To braze and solder, you have to recover the refrigerant fully. Do not ever braze or solder when there's refrigerant in a system. You want to ventilate the area. You need to wear personal protective equipment. You need to check brazing equipment for leaks and proper pressure settings. And you want to purge with an inert gas such as nitrogen while brazing. You should only people brazing should be trained and qualified people. So let's talk about the purging with inert gas while brazing. What you want to do is run a very, very small quantity of gas through the tubing as you're brazing. Okay, this is very important. First, it cuts down on oxidization, and second, it pushes away any flammable material that may have settled in the system. We have to talk about the rated equipment. Okay, flammable gas and leak detectors and monitors, explosion-proof recovery equipment. Okay, you cannot use the standard recovery equipment on hydrocarbon refrigerants. Everything has to be sealed so that motor windings, switches, and everything else do not provide a spark. Okay, flammable gas leak detectors would be the same leak detectors you would use on natural gas systems. You do not use standard refrigeration leak detectors on hydrocarbon equipment. Gas monitors would be just the standard like propane gas monitors or flammable gas monitors that can be installed. Okay, you want to install them near the floor level because these refrigerants are heavier than air and they will pool down around the floor or the lowest point. All refrigerants in confined spaces have inherent dangers. Okay, confined space, machine rooms, equipment rooms. Remember to monitor. You want to use combustible gas detectors and monitors. You need to ventilate. You need to clear the area of any potential LEL or UEL situations. You want to remove all sources of ignition. So it's MVE, monitor, ventilate, eliminate. The refrigeration cycle is not all that different from the standard cycle that you've learned about forever, okay? We have a compressor, okay? Terminal venting or without terminal cover, okay? We need to consult the compressor manufacturer for any special requirements. You want to disconnect all electric from the system while monitoring. You want to locate the unit for preventative ventilation, and you want to connect your gauges to the high and low side with proper system access. You want to use tubing cutters, not a torch. To install a compressor, you want to braze. Okay, assume soft solder will fail. Or you can use mechanical methods of connection, such as flares and compression. Don't use compression fittings. You want to use flares, and just the compression means you're tightening it down hard. We have a condenser, we have an evaporator, we have a metering device, and we have lubricants. Okay, the components of a system are similar to regular systems. As all systems are new equipment, the engineering of all the components is complete. You always want to manufacture the manufacturer guideline requirements. Only use factory designed and approved components. All components should be labeled for use with flammable refrigerants. To service, you want to use spark-proof equipment like a brass screwdriver. You want to do leak testing outside the cabinet and inside the cabinet. You want to evacuate and pressure test using nitrogen. You want to make sure we do recovery properly. You want to charge properly by weight. You want to make sure you adhere to refrigerant purity. And you want to be careful on part replacement. One note on leak testing. When leak testing, only use non-ignitable type detectors such as UV additive, liquid detection solution, electronic leak detectors designed for flammable gases, or ultrasonic leak detectors. So that is an overview of the refrigeration safety for the R290. Okay, I encourage you to get the manual from HVAC Excellence, and I encourage you to take the HVAC Excellence exam. That is an open book exam, I believe, and you can take it through the HVAC Excellence website. I'll put that in the comments on this video.